SK Hynix dropped 6%, Samsung dropped 5%, Micron, SanDisk, all of them cratering. Not because of a trade war, not because of a recession, because of a research paper. Google just published an algorithm called TurboQuant that compresses the memory AI models need by 6x with zero accuracy loss. And Wall Street immediately realized, what if the $100 billion memory chip build-out everyone's been betting on just became unnecessary? This is the most consequential AI paper of the year, and it might have just killed an entire industry's growth thesis. Let me explain. To understand why this matters, you need to understand how large language models actually work under the hood. When an AI model like GPT or Claude processes your prompt, it doesn't just read your words and forget them. It creates what's called a key value cache. Basically, a running memory of everything it's paying attention to. Every token, every relationship between words, stored as numerical values so the model can look back and maintain context. Here's the problem. These KV caches are enormous. For a model with a 1 million token context window, the cache alone can eat hundreds of gigabytes of GPU memory. That's not the model weights. That's not the computation. That's just the memory of what it's currently thinking about. This is why AI companies are spending tens of billions of dollars on memory chips. NVIDIA's H100 GPUs are expensive partly because of the high bandwidth memory strapped to them. SK Hynix basically prints money selling HBM chips. The entire AI hardware thesis assumes that models will always need more memory, so you'll always need more chips. TurboQuant says, what if you don't? The core idea is deceptively simple. TurboQuant quantizes the key value cache down to just 3 bits per value. Normally, these values are stored in 16-bit floating point. That's 16 bits of precision for every single number in the cache. TurboQuant compresses that to 3 bits, an 80% reduction, while maintaining essentially the same accuracy. How? The algorithm analyzes the statistical distribution of cache values and finds that most of them cluster in predictable ranges. Instead of storing every value with full precision, it uses adaptive quantization, grouping similar values together and representing each group with just a few bits. Think of it like JPEG compression for your photos. A 16-megapixel image has millions of unique color values, but JPEG figures out that huge regions of the image are basically the same shade of blue, so it stores one value for the whole region instead of millions of individual values. TurboQuant does the same thing for AI memory. 6x less memory usage, up to 8x faster attention computation on NVIDIA H100 GPUs. No training required, no fine-tuning. It's a drop-in optimization you can apply to any existing model. The internet immediately called it the real-life Pied Piper from Silicon Valley. Middle-out compression, but for AI. Here's where it gets serious. The entire AI infrastructure investment thesis rests on one assumption. AI models need exponentially more compute and memory, so companies must keep buying exponentially more hardware. NVIDIA's data center revenue went from $15 billion to over $100 billion in 2 years. SK Hynix's HBM business grew 400%. Samsung invested $20 billion in memory fab expansion. Micron committed to a $100 billion factory in New York. All of that investment assumes demand for memory keeps growing, but TurboQuant is a software solution that reduces memory demand by 6x with no downside. If every cloud provider deploys this, and there's no reason they wouldn't, it's free performance, then the memory chips they were going to buy next quarter, they might not need. The market did the math instantly. SK Hynix fell 6%, Samsung fell 5%, Micron dove, SanDisk sold off. Billions of dollars in market cap evaporated in a single trading session. And this paper is being presented at ICLR 2026, one of the most prestigious machine learning conferences in the world. This isn't a random archive preprint. This is Google's A-team research, peer-reviewed and ready for deployment. But here's what I think most people are missing. TurboQuant isn't happening in isolation. It's part of a pattern that should terrify anyone who bet their career on AI needs infinite hardware. Earlier this month, Alibaba's Qwen 3.5 model, just 9 billion parameters, beat OpenAI's GPT-OSS 120B on the GPQA Diamond benchmark. A model 13 times smaller outperformed the big one. Scale alone is no longer the moat. Google's Gemini team has been publishing compression research all year. Meta's Llama team is doing the same. Every major AI lab is converging on the same conclusion. We've been brute forcing AI with hardware when software optimization can get you most of the way there. This is what happened with cryptocurrency mining. Early on, everyone assumed you needed exponentially more hardware. Then, efficiency improvements in mining algorithms meant you could do more with less. The companies that bet everything on hardware expansion got destroyed. Now, I'm not saying memory chips are dead. AI is still growing. Models are still getting bigger. But the rate of growth in hardware demand, that just got a serious haircut. And in the stock market, growth rate is everything. A company can be printing money and still see its stock collapse if growth slows. The question Wall Street is asking today: is TurboQuant the beginning of a compression revolution that makes the $100 billion AI hardware build-out a stranded asset? Let me put this in perspective. In the history of computing, every major hardware build-out has eventually been disrupted by software efficiency. Mainframes gave way to PCs. Dedicated servers gave way to virtualization. On-premise storage gave way to compression and deduplication in the cloud. Every single time, the market overbuilt hardware, and then software made most of it unnecessary. Are we watching the same thing happen to AI infrastructure? 6x memory compression with no accuracy loss. 9 billion parameter models matching 100 billion parameter ones. Efficiency improvements coming from every major lab simultaneously. Maybe the era of just throw more GPUs at it is ending faster than anyone expected. And if it is, the companies that adapted to efficiency will thrive, while the ones that bet everything on scale will be left holding very expensive, very unnecessary hardware. Google just published one algorithm and wiped billions off the memory chip market. TurboQuant compresses AI memory by 6x with zero accuracy loss, and it works on every existing model today. The $100 billion AI hardware build-out just met its first real threat, and it came from a research paper, not a competitor. If you want to understand how AI infrastructure is actually evolving, not the hype, the real engineering, subscribe, because the compression revolution is just getting started.